So the last speaker of today's session is Dr. Lovedeep Kaur. And Dr. Kaur specializes in food biochemistry and nutrition, and she has a particular interest in exploring the use of in vitro digestion models to understand structure-function digestion relationships in foods. She is a senior research officer at Massey University and is also an associate investigator in the Lovedeep Kaur. She also serves on boards of food journals and academic institutions. She has produced more than 100 publications in her research career and has also co-edited 2 books published by the academic press. And the title of her presentation today is Nutritional and Functional Quality of Potato Protein. Thank you, Dr. Kaur.
Thanks for the kind introduction, Caroline. Good afternoon, everybody. So today I'll be just providing an overview of the nutritional and functional properties of potato protein, which has gained a lot of attention these days because of the rise of plant proteins in general. So first of all, I would like to explain a little bit about what's happening in the potato protein market. So the potato protein market is expected to grow at compound annual growth rate of 7% to US dollars 168 millions by 2024. So this rise is expected because of the surge in demand for plant proteins worldwide. So the potato protein is currently mainly used in sports drinks and weight management supplements, and global food processors are looking to replace animal protein partially or completely with plant proteins, and some of them are quite interested in plant proteins. You would have seen the labels of some of the very popular meat alternatives which are using potato protein as one of the ingredients. So potato protein has huge potential to fulfill consumer demands related to health, premium quality, clean label, and convenience, but consumer awareness is still low compared to other proteins. So potatoes are mainly used for the production of potato starch, which finds a lot of applications in foods. So and that leaves a byproduct, which is potato juice, which is still rich in proteins and contains about 35% protein. So potato protein can be easily isolated from the potato juice through different methods like precipitation, acid-alkali precipitation, heat coagulation, membrane separation, etc. So all these methods, they lead to different recovery rates and different quality of the protein at the end. So potato protein has the ability to offer functional properties like animal protein and has very high biological value compared to other plant proteins sources, so making it a very good source of protein fortification in a range of food products. So it's allergy-free. It imparts no characteristic odor of its own, unlike many other plant proteins like soy or pea, which impart some somewhat beany flavor to the food products. So, and at the same time, it's easy to isolate. Although it's highly functional compared to many other plant proteins, its functionality can still be tailored for different foods using different physical, chemical, and enzymatic modification methods. So potatin is the most promising protein fraction. So there are 3 different categories of proteins: potatin, which is present at 40%, and protease inhibitors 40% again, sorry, 50%, and other proteins 10%. So naturally, it's present as a dimer for the molecular weight of 88, but when you use it can be degraded to monomer units when you use SDS-PAGE, as you can see on the right-hand side. So potatin has very good emulsifying and forming properties. Its forming ability and stability is even comparable to or superior than egg white protein. So it finds applications in baked products. So it can be modified in order to further improve its emulsifying capacity and stability. In terms of the nutritional attributes, the most plant proteins are limited by lysine and sulfur amino acids like cysteine and methionine, but potato protein has sufficient concentrations of both essential amino acids to meet the requirements of infants and young children. So potato protein is again at the same time very highly digestible and has high PDCAAS and DIA score, as you can see on the right-hand side. So a DIA score of 100 or above indicates that none of the amino acids present in the protein is limiting, and the sole protein source should be able to meet physiological requirements. In this case, in this study, if you look at the graph on the right-hand side, you see potato protein egg protein, casein, and pork going above the 100 mark based on 0.5 to 3-year-old reference pattern. So we can say that the nutritional quality of potato protein is quite comparable to animal proteins like meat and milk protein and egg protein as well. But then I just want to say that potato protein has the potential to meet the demands of or to combat malnutrition, like some of the vulnerable population in lower middle class countries. So the application of potato protein should be explored in food products, particularly for those vulnerable population groups, and also for the general population that's demanding high quality, sustainable, clean label food products. So potato protein can find application in foods for those population groups as well. Thank you very much for listening.
Thank you, Dr. Kaur, for explaining the potential uses of potato protein.